Welcome, Rare family, to this tutorial where we are going to look at the introduction of limits. So, I'll start with the definition of limits as the objectives are stating here. Then I'll come to the laws of limits. So these here are the laws of limits regarding the theorem 1. So this is the first theorem. Theorem 1 of limits, which has got these rules. There are so many rules, you'll see them as we go on, but in this tutorial it's just the introduction. So without wasting much of the time, let's get to introduce the limits. Alright, so limits, according to the definition I'll give you, I'll simply say I want to give you the very simple example which won't confuse you. So limit is just a mathematical operation which will simply enable you to identify some properties of a function. Remember, you were learning about functions. So this function f of x, let's say, let me draw it here. This is the y and this is the x axis. Then you've got this function here, f of x. Then at a certain point, let's say this point is 2. So what happens to this function as x approaches 2 is very important. As mathematicians, you have to know properties of functions. What happens to your function when x is approaching some value, like this one? What happens to this point, to this function, when x is approaching this value, which is 2? It's very important. So limits are used to identify function properties, to really know what happens to that function at a particular point. That's the very basic introduction I can give you, or the definition I can give you to limits. Let's go. We see how limits are denoted. Limits are denoted in this form. Limit as x approaches a certain constant of the function. The function can be g of x, x of x. I don't know how you denote your functions, but I like f of x. And this function should be equal to a certain value. So this is the limit value, which will enable you to tell what happens to this function at that particular point. So in this case, we can say limit as x approaches 2 of this function should be equal to a certain value. Let's say the y value here is 1, meaning limit as x approaches 2 is equal to 1. Why are limits important? Let's get to see this. Before that, I would like to write down these rules here. Existence of a limit. Existence of a limit. Sometimes you might be asked questions on limits to tell whether the limit exists or not. So what determines the existence of limits? Just this simple rule. There are two types of limits. The first one is the one-sided limit. One-sided limit. And the second one is the two-sided limit. So let me give an example of these two. A one-sided limit is something which looks like this. Limit as x approaches some value, which is c. When you see this positive sign there, it means the limit is coming from the right hand side. So x is approaching a certain number from the right hand side of f of x, which is the function, should be equal to L. So let me just reduce this so that I give you another example of a one-sided limit. Another example is the one which comes from the left hand side. So limit as x approaches c from the left hand side. So this negative sign means from the left hand side, meaning as x approaches a certain number. So in this case we've got 2. As x approaches 2 from the left hand side of the function, it should also give you a certain value, which is L. Then a two-sided limit, it is just this one we have. It's a general one. It's not showing whether this is coming from the right hand side or left hand side. So this is a two-sided limit, the one which looks like this. Limit as x approaches a certain number of the function should also be able to give you a value which is L. So the existence of this function depends on the two-sided limits. Let's take a look at this. If I reduce this, let me reduce this. Let's do this. Okay. Okay, I didn't do it well. Let me repeat the thing. Alright. Okay. Let me reduce it. Do something like this. And I do this. Alright. What have I done? Okay. Like this. So, the existence of this limit, if it exists, the limit as x approaches a certain value from the right hand side of the function should be equal to the limit as x approaches a certain number from the left hand side of the same function. That's how you can conclude if the function exists. So if, as you can see, the two-sided limits is giving me L just by example in the formula. Even the two-sided limit should have the same value like this. So let me erase this and give you a practical example to this question using the same graph I've drawn there. So let me do this. I just minimize this. Okay. Alright. Then I draw a very good graph which denotes a certain function. So this is y and this is x. Then I've got this function. So this is 1. This function is f of x. Then this is 2 in the y-axis, -1. So let us try to find the limit as x approaches 2 of this function. So limits can be solved using so many approaches. So this approach is called the graphical approach. where you'll be given some graphs. Then you'll be expected to be giving limits according to your observation. Just observe the x or y plane. It depends on the y value and the x value. So the x value is the one which is being approached. Then the y value is the limit answer. So don't make a mistake. The y value is the limit answer. So what is the answer to this? When x is approaching 1. I'm sorry, I wrote 2 here. It's 1. When x is approaching 1. So for you to answer this one, the right procedure is that you start with the one-sided limits, because this is the two-sided limits. So you can't be sure of the answer. You can find it. I'm able to see it. In fact, even you are able to see it, but don't go direct solving from here. Always start with the two-sided limits. So by doing that, I'll start with this one. Limit as x approaches 1 from the right hand side of f of x is equal to a certain number. So what is the function? We said the limit should be the y value. So as x approaches 1 from the right hand side, so right hand side is this one. X is approaching 1, as you can see. It's approaching 1, coming down there, approaching 1, approaching 1, approaching 1. So as it approaches 1, what is the y value? That's the limit we are looking for. The y value, as you can see, is what? 2. Right? This is simple. Just go through this video 2 or 3 times, you'll be able to understand. So having said that, let's go to the limit as x approaches 1 from the left hand side of the same function. So left hand side, you are approaching 1 from this side, meaning it's going up there, up there, up there, up there, and it approach 1. So what is the y value when this limit approaches 1? What is the limit? The limit is the y value. I'm sorry. What is the limit when x approaches 1? So again, the y value at 1.1. So this is equal to 2. So from here, you may now conclude. Make sure you conclude to say limit as x approaches 1 from the right hand side of this function equals limit as x approaches 1 from the left hand side of this function, which is equal to 2. Then you say, therefore, the limit as x approaches 1, limit as x approaches 1 is basically what? 2. And if you are told to conclude whether this function or the limit exists or not, you can tell from this conclusion, because these are equal. Meaning if the limit as x approaches 1 from the right hand side and the limit as x approaches 1 from the left hand side are equal, it means the function or the limit exists. I hope you get something. So this is how you go about it, solving for this question. Now there is one other question which may come on the same graph. So before I go to that one, let me do this. Let me reduce this. Let me reduce this. Let me reduce this. Okay. So the other one, since we said limits are there to tell what happens to a particular function at a certain point. So you might be asked to find the limit as x approaches 1 at f of 1. At f of 1, meaning to find the function at f of 1, remember the polynomial rules. If you've got something like this, f of x is equal to x squared plus x, like this, then if you are told to find f at a certain number, meaning you have to substitute your number in your function there, like this, plus x or plus c. You've substituted where there is x, you put the number. So even in limits, if you are told to find f at 1, meaning you have to plug in your value, which is 1. So in this case, it's a graphical way. It's a graphical representation. We don't have the values of this function, but we've got something which will enable us find the value. F at 1, you're checking the y-axis. What is the value? Is it 2? So when you're asked to find f at 1, it means you are being told to find the continuity. No wonder this topic is called limits and continuity. That's one property of a function. Is this function continuing? Is it continuing? Is there continuity? Is there a disjoint in that function? So with that, you'll be able to tell with these symbols. These symbols, we've got the closed circle, which is shaded, and the other one which is open. This means the number is not included where there is this symbol, and if there is a shaded one, it means the number is included. So f at 1 does not exist, is 0, because f at 1, there is an open circle, meaning you cannot find the value of f at 1 where there is an open, so it means 1 is not included. Remember what you learned in semester 1? In semester 1 on set interval notation, it means 1 is not included. So f at 1 is 0, it's not included. Let me give you this one. This is shaded, then here I give you 0.5. So f at 0.5 is included, meaning you can find the value at f at 0.5. You can find the value of f at 0.5. What is f at 0.5 is basically the y value there, which is 1, meaning you are able to tell the properties of the function you have. That's the definition I gave you of limits. It's there to tell you the properties and the type of the function you have. What happens to a particular function at some points of the x-axis. So in this case, f at 1, there is continuity there. It is continuing, meaning the value is 1. It is included. But f at 0.5, there is no disjoint because it's included. Say continuous function from there 0 up to before 1 somewhere there. But at 1, there is a disjoint, meaning there is no continuity there. It's a 0 because f at 1 is not included. 1 is not included. But as x approaches 1, we've got a value, which is this limit. But the function at 1, you cannot substitute 1 there because 1 is not included. So another question might arise to say, but why? The limit as x approaches 1 is 2. Why? When f at 1 is 0, 1 is not included. Why? So if that question comes up, here's the answer. Make sure you follow it up. Let me erase this. Let me erase everything. Then I start explaining that question. When there is an open circle at a certain number, in that case we had 1. Let's say 1 is here. This is the x-axis and this is the y-axis, like this. Then this is the function f of x. Then there was a 2 here, meaning we said the limit as x approaches 1 is equal to 2. Let me give you an example of this. Consider our function f of x is equal to x squared minus 1 over x minus 1. So as you can see, if I put f at 1 here, I'm going to have 1 squared minus 1 over 1 minus 1, which is basically what? A 0. So 1 does not equal the x value. No wonder that circle there. 1 does not equal the x value. No wonder that circle there is not closed, meaning x is not equal to 1. When you put 1 there, the function will be 0. Which is undefined. You've seen? But let us do this. Instead of putting 1 there, it means the other values there, the ones which are closer to 1, are included. The ones which are closer to 1 are included. Let's do this. Let's take the limits from, this is the right hand side, and this is the left hand side. The left hand side. We select the numbers which are closer to 1. We put them here. Put them in this box. Just three numbers. Then you'll be able to tell why the function exists, but the value at f of 1 does not exist. It's 0 when you've got that open shape. So from the right hand side, I'll pick 0.1 or 1.1, sorry, or 1.01 is this side from the right hand side, right? 1.01. You can also put 1.001. It's fine, it's closer to 1. You can also put 1.0001 like that. Then from the left hand side, I can get 0.9. Can also get 0.09. Can also get 0.009. This number is closer to 1 from the left hand side. Then from the right hand side, these are numbers which are closer to 1. The closest numbers, please, I emphasize, get the, because it's saying as x approaches 1. So you are approaching 1, make sure you get the numbers which are really closer to 1. I repeat, it's approaching 1. Get the number or the numbers which are really closer to what? To 1. Or any number you've been told, get the closest numbers. It can be x approaching 2. Get the closest number to 2. You substitute in your function. So if you put 0.9 in this, it will be 0.9. You put 0.9 where there is x there in the function. So when you put 0.9 where there is x in that function, let's say 0.9 squared minus 1 over 0.9 minus 1. So if you put that, you work out that 0.9 squared minus 1, 0.9 squared minus 1, this is negative 0.19, like that, over 0.9 minus 1, that is negative 0.1. When you divide this negative 0.19 divided by 0.1, you get these negatives will cancel, of course. You get 1.9 here. So my answers, I'll be writing them in blue ink. You get 1.9. It's from the left hand side. Don't forget, left hand side, and this is the right hand side. So again, when you put 0.09, so I add the 0 there, 0.09 squared minus 0.09, there I put the 0.09. You find that the answer there will be 1.99. When you put 0.009, so you can try this on your own, you find that the answer will be 1.999. Okay, let's do it from the right hand side. We see, so from the right hand side, when you put 1.01 in the function, squared minus 1 over 1.01 minus 1, the answer will be equal to this. Let's say 1.01 squared minus 1, the answer is 0.0201 over 1.01 minus 1, the answer is 0.01. When you divide the two, 0.0201 divided by 0.01, the answer will be 2.01. When you continue the same procedure of substituting, you find that this will be 2.001 and this will be 2.0001. So if you round off 1.9 to the nearest whole number, you'll find that this is equal to 2, and this is also equal to 2, this is also equal to 2, and when you round off this to the nearest number, find that this is also equal to what? 2, and this is also equal to what? 2, this is also equal to what? 2. No wonder the limit as x approaches 1 from the right hand side of the function gave us 2, and the other one, the limit as x approaches 1 from the left hand side of the function gave us 2, meaning a two-sided limit, which is limit as x approaches 1 of the function is equal to 2, meaning this function exists. But if you put this f at 1, you substitute 1 there, it will give you something else which is undefined. So f at 1 is equal to 0. So make sure you know how to deal with these kind of things. So this is the analytical way of solving limits, and that one, the previous one, was the graphical way. So you can choose which method you like. It's up to your choice. The graphical one is very simple, but in some questions you don't have a choice to choose, because they'll give you something which is not a graph. They'll give you a question maybe in an analytical way, numerical, something like that. So you should know all the methods. Make sure you take note when you're given a graph. Take note of the notes, the circles. Where there is a closed circle, it means the value is included. You can substitute it directly if you want, but if there is an open circle, just know that the number is not included. F at that number is undefined when there is something like this. It means x should never be equal to that number when there is an open circle. So by definition, I think this is great. You are able to have a clear picture of limits. You won't be confused. Most of the details will be talked about in the upcoming videos, in other videos, since this is just the introduction. Hope you get something on this one. Let's go to the laws of limits. Allow me to wrap this. Just erase everything. Erase this. We talk about the laws. So law number one is sum rule. Sum. Let's say the limit as x approaches some constant number of a certain function is equal to L, like this. Then this is limit 1. Limit 2, we've got limit as x approaches some constant number of f of g of x, because this is another limit. G of x is equal to m. These are just examples. Don't be confused by the letters. They're just there to make you understand. Okay, so let's do this. If you are told to sum up these two limits, this plus this is equal to L plus M. Don't be confused. Just find the limit of this function alone, you get the value. You also find the limit of this function, you get the value. Then you come and add the values you get at the end. So this is what the sum rule is all about. You are allowed to solve this one alone. You come and solve this one alone as well. Then you sum up the answers. So this is the sum rule. Hope you're not confused. So let me give an example. Limit as x approaches 2 of this function, 2 of x, 2x I mean, sorry. Then you have got this limit as x approaches 1 of x. So these are limits x. So I can solve this one. Limit there, I can go direct and substitute. I put 2 there, meaning the limit to this is actually what? 4. Then here, if I substitute there, where there is x I put 1, the answer is just what? 1. So using the sum rule, I can come here direct and sum up the limits I found, 1 and 4. So that's what the sum rule states. I can come here and add this. Then the answer will be 5. Hope this is clear. This is clear. This is the sum rule. These are just basics. Make sure you don't do away with this, because you won't be able to solve anything if you do away with the basic principles. Let me erase this. I go to the difference rule. Difference rule is just the same as sum rule. Difference and sum rule are just one and the same, except that the sign changes. Where there is a positive sign, there will be a minus sign. So this one states that the limit as x approaches some constant value of f of x plus the limit as x approaches some constant value of g of x. So if this is equal to m and this is equal to L, minus is difference rule, meaning this is equal to L minus M. So that's one and the same. Such that this time around the sign has changed. Hope you understand. When we go to the product rule, you can see, so we've done sum rule, difference rule, product rule. So the product rule, again, it's just one and the same. Product It's the value you find after multiplying something. So if this is equal to this, then there is a multiplication sign here, meaning you're going to just do this. Multiply the values you find or the limits of the functions. Simple. Quotient rule, just if there is a division sign there, just divide them like this. Then you find your answer. So quotient rule, we are done. And product rule. Even this, we are done. Let me tick. That's changing. It's the same principle, but just change the sign and do the needful. You know, where there's a multiplication sign, multiply everything. Where there's a subtraction sign, subtract. Just like that. So let's talk about the power rule. The power rule. The power rule, in case you have a polynomial like this, a function f of x is equal to 2x. Then they ask you to find the limit as x approaches 1 of f of x. Now in this case, squared. There is a power there. This power should never be a negative power. It should always be a positive power. So this is power rule, positive power. So this means this is equal to this. The limit as x approaches 1 of this function, just substitute, you put 1 there. You see? Then the value you find is 2. Then you come and square it. So the formula is like this. Limit as x approaches 1, this is the power rule, of the function which is squared, so it approaches some constant. This is equal to this. L squared. L stands for the limit you get, as you've been observing from where we are coming from. You can use any letter of your choice. This is just by example. So don't be bothered to start squaring this, then you come and put in the limit. Find the limit first, then you square the limit. So in this case here, the answer is what? 4. That's the power rule. It's very simple. You don't have to be stressing or what. It's very simple. Just pray that you know how to play with your mathematics very well. Remember each and every basic you've been given from grade 1 up to where you are. It's very simple. Then we come to the root rule. Root, again, the root rule states something like this. As x approaches some constant of f of x, then this is in a root, like this, in a square root or cube root, any root. This is equal to L of that root. That's the answer. Again, if you find that limit as x approaches some constant of this function, the answer is equal to something like L. So you find the limit first, then you put in the square root. That's the root rule. Alright, so it's just one and the same. We come to the constant multiple rule. The constant multiple rule says that if you have a limit as x approaches some constant value of a constant number, the answer is that same constant. What do we mean by this? If you have got something like this, when x is approaching 1 of 10, meaning the answer is just what? 10. The answer is just 10. Don't be confused. You start solving, where am I going to put this one? The answer is just 10, because 10 is a constant, doesn't have any variable. So this is how you can do it. So I hope you understand. These are the basics of limits. In the next tutorials, we are going to look at the evaluation of limits, where we'll be solving some questions on limits. Alright, Team Rare. So in this tutorial, I'm going to solve questions on limits under the topic evaluation of limits. Okay, so to start with, I'll start with this question. Finding the limit as x approaches infinity, negative infinity of this x plus the root of x squared minus 4x plus 1. So here you don't know the number to replace in this. So firstly, you have to multiply this by the conjugate. So this is same as over 1. Multiplying by the conjugate will be x minus, so this is multiplication, x squared minus 4x plus 1. Brackets, even down here you multiply with the conjugate, x squared minus 4x plus 1. So if you work out this, you'll find that this will be equal to this limit as x approaches negative infinity of, it will be like this, x squared minus x squared minus 4x plus 1. You know where this one has come from. When you multiply this and this, let me show you here aside. When you multiply x and x, it will be x squared. When you multiply x times the root, this root, it will be minus x times x squared minus 4x plus 1, like that. And when you multiply this by that, it will be plus x times x squared minus 4x plus 1. This is x. When you multiply this by that, it will be negative x squared minus 4x plus 1 in brackets, because when you multiply a root and another root with the same radicand there, this will just cancel themselves. You will remain with just x. That's what the rule says, because this is the same as doing this. Let me wrap this. It will be x times x, which is equal to x squared, and the root will cancel that power, and the answer is just x. No wonder I'm having this. But down here I'm going to have x minus x squared minus 4x plus 1. This, when I distribute this, this will be limit as x approaches negative infinity. You see that this and this will cancel. You remain with 4x minus 1 over x minus the root of x squared minus 4x plus 1. So here, when you reach here, you are going to divide both the numerator and the denominator by the variable which is having the highest power in the denominator. So the variable having the highest power here is the root of x squared. So the root of x squared, you're going to divide both the numerator and the denominator. So solving that, let me reduce this so that you are not lost. Okay, this is where we've reached. Let me continue. So this will be limit as x approaches negative infinity, it will be 4x over the root of 2x squared minus 1 over the root of x squared over x divided by x, the root of x squared minus this x squared, so this is x squared, sorry, x squared minus 4x over x squared plus 1 over x squared. So you've seen this x, this square, this power will cancel with this power will cancel with this, and this x will cancel with this. Then this power will cancel with this x will cancel with this one. Here there will remain 1, there, here it's 4, then here it's 1, then here it will remain like this. Limit as x approaches negative infinity of 4 minus 1 over x divided by 1 minus 1 minus 4x plus 1 over x squared, like that. Let me reduce them again. Okay, I'll just stop from over. Let me do this. Let me just rub this. So from here. Okay. Excuse me, I've got the flu. Alright, so here the rules states that limit as x approaches positive or negative infinity of functions which have got a number here with a denominator having a power like this, they are equal to 0. So let us distribute this limit to all the numbers we are having there. It will look, so distributing this will look like something like this. Limit as x approaches negative infinity of 4 on top there, and you put them in brackets like this, over limit as x approaches negative infinity of this 1. Let me do something. Yeah, of 1 minus the root of 1 minus 4 over x plus 1 over x squared, like that. So here the answer will be 4 plus 0, because this falls under this condition. You've seen it can also be like this, any number over the variable, let's say x. Even here you put some x, so that's one and the same. Anything over x, when you take the limit to positive infinity or negative infinity, it will be equal to 0. No wonder this part will be 0. Down here will remain with 1 minus the square root of 1 minus 0 plus 0. Hope you are getting it. This 0, these are zeros, meaning this will be equal to this will be equal to 4 over 1 minus the root of 1. This is equal to 4 over 1 minus, then plus or minus 1, because the square root of 1 is plus or minus 1. Then here you get the positive 1, because if you get you get the negative 1. If you get the positive 1, this will be undefined, so you get the positive 1, or the negative 1, I'm sorry, which will be 1 minus negative 1, like that. Then when you work out this, you find that the answer there will be 4 over 2, which is equal to 2. So solving this yields to this answer, which is 2. Alright, so rare family, in this tutorial I'm going to solve this question. Someone requested for this, wanted an answer to this one, so I prefer starting with the same one. Alright, so here when you just see x approaching infinity, the rule you should put in mind is this: the limit as x approaches infinity of any number over x is equal to 0. Even this limit as x approaches infinity of any number over x to the power something is equal to 0. So the first step here, we need to check the number with the highest power, or the variable that has got the highest power. So in this case we've got 2x to the power 3. So we are going to divide this throughout with x to the power 3, like this. Okay, let me redo. Alright, so this will be limit as x approaches positive infinity of 4x to the power 3 over 2x to the power 3 plus x over 2x to the power 3, this over, so you've seen I've divided all the variables I have there with the number with the which has got the variable with the highest power of the denominator. So this will be x squared over 2x squared minus 2, this is x to the power 3, sorry, 2x to the power 3 over 2x to the power 3. So this and this will cancel, give us 1, and this will cancel, this will cancel, here to remain x squared, then this will cancel, this will cancel, this will give us a 2, and this will cancel with this, and we are going to remain with something like this: limit as x approaches positive infinity of 2 plus 1 over 2x squared divided by 1 over 2x plus 1, like this. So here you now take the limits of this following these rules. So anything with the x under, or anything with x under the denominator there, it's going to be 0 when we take the limit. So this will equal this will be 2 plus 0 over 0 plus 1, which is just equal to 2 over 1, which is equal to 2. So that's the answer to this question. Hope you enjoy it.